Analyzing graph of functions. This video explains vertical line test, zeros of functions, increasing and decreasing function, average rate of function, even and odd functions. What is the graph of a function? The graph of a function f is the collection of ordered pairs x comma f of x, where x is the domain and x is directed distance from the y-axis, and y is equal to f of x is the directed distance of a point from the x-axis. What is vertical line test? The graph of an equation defines y as a function of x if any vertical line drawn through the graph intersects the graph at exactly one point. If the vertical line drawn through the graph intersects the graph at more than one point, then the graph does not define function. Example. Here is a graph. We want to know if this graph represents function. So you draw a vertical line anywhere, and it intersects the graph at exactly one point. So this graph represents function. Here's another graph. Now, if you draw a vertical line anywhere, like just this one, it intersects the graph at this point and this point, which means vertical line intersects graph at 2 points. So this graph is not a function, or this graph does not represent function. Zeros of function. What are zeros of function? The zeros of a function y equals to f of x are the x values for which f of x equal to 0. This suggests to find the zeros of the function, you have to set the function equal to 0 and then solve the equation for the variable x. Example. Here we have a function f of x equal to 5x minus 15, and we want to find the zeros of function. So accordingly, we have to set the function 5x minus 15 equal to 0. And now we solve for x. So first we remove negative 15 and take it to the right and make it positive. Now divide both sides by 5. So it becomes 5x over 5 equals 15 over 5. Simplify, it gives you x equal to 3. So 0 for this function is 3. Finding the zeros of a function. F of x equals 5x squared minus 3x minus 2. So we set the function equal to 0. And now it's a quadratic equation, so we try to factor. Factors of minus 2 would be plus 2 and minus 1. And 5x squared, the factors of 5x and times x. And now we can check 2 times x, 2x, 5x times negative 1 is negative 5x. And if we add negative 5x into 2x, it gives you negative 3x. While we multiply 2 times negative 1, we negative. So these are correct factors. Now we set each factor to 0. 5x plus 2 equal to 0. Take 2 to the right, it becomes negative 2, and then divide by 5 to become x equal to negative 2/5. So this is 1, 0. To get the other 0, we set the second factor to 0, x minus 1 equal to 0, and move the negative 1 to the right, it becomes x equals to 1. So the zeros of this function are negative 2/5 and 1. Okay, so let's find the zeros of this function. F of x equals to x minus 5 over x squared minus 9. As usual, we set this to 0. And now, since a rational function equation, so we find the LCDs and there is only one fraction. So the LCD is x squared minus 9. So we multiply both sides by x squared minus 9. So we have x squared minus 9 times x minus 5 over x squared minus 9 equals to x squared minus 9 times 0. Well, this goes to 0, and this we can cancel out, and we get x minus 5 equals 0. Now we move the negative 5 to the right, and it should become positive 5. So the 0 is x equals to 5. What is the interval of increasing behavior of a function, and how we find the interval of increasing behavior of function? Well, the interval of increase of a function is the interval of all x values for which the graph of function is rising. And to find the interval of increase of a function, we'll look at the graph of function from left to right. The smallest x value where the graph starts rising is the left endpoint of the interval of increase. The largest x value where the graph stops rising is the right endpoint of the interval of increase. So the interval of increasing behavior of function is smallest x value to largest x value. Please note that you can have more than one interval where function could be increased. Finding the interval of decreasing behavior of function. The interval of decrease of a function is the interval of all x values for which the graph of function is falling. To find the interval of increase of a function, look at the graph of the function from left to right. The smallest x value where the graph starts falling is the left endpoint of the interval of decrease, and the largest x value where the graph stops falling is the right endpoint of the interval of decrease. So the interval of decrease of a given function is the smallest x value to largest x value. Again, you can have more than one interval where function could be decreased. Finding the interval of constant behavior of a function. The interval of constant behavior of a function is the interval of all x values for which the graph of function is neither falling nor rising. To find the interval of constant behavior of a function, we can look at the graph of the function from left to right. The smallest x value where the graph stops falling or rising is the left endpoint of the interval of constant behavior. The largest x value where the graph starts falling or rising is the right endpoint of the interval of constant behavior. Smallest x value come to largest x value. Again, you can have more than one interval where function could exhibit a constant behavior. Okay, so now we look at the graph from left to right. So if you go from this extreme up to -1, the graph was rising, but when you reach here, it starts falling. So we will say from minus infinity to -1, the graph is increasing. And then keep going from -1 is falling. So we will say it's decreasing from -1 to 1. And then if we keep going from 1 to the right, the graph is going up. So we will say it's increasing from 1 to infinity. So here's the answer. Increasing over minus infinity to -1 and 1 to infinity, while it's decreasing over or decrease on -1 to 1. Here's another example. To find out where the function is increasing, decreasing, or constant. So we look at the graph from left to right. So if you go from coming from minus infinity to up to this, where the x is -1, the graph is decreasing. But then from -1, so we're looking at the x value, not the y. -1 to +2. It stays steady, I mean it's neither falling nor rising. And then from 2, keep going to the right, the graph is going up. So we'll say it's increasing. So the answer is the graph is decreasing from minus infinity to minus 1. It stays constant from -1 to +2. It's increasing from 2 to infinity. Next, we're going to learn how to find the average rate of change. Average rate of change of function f of x from x value x1 to x value x2 is simply the function value evaluated at x2 minus the function value evaluated at x1 divided by the difference of the x values x2 minus 1 x1. So here is an example. So we are given a function f of x equal to -3x plus 10, and we're given the x values. X1 is 2 and x2 is 7, and we have to find the average rate of change of this function. So first we're going to find f of x1, where x1 is 2, so that means we have to find f of 2. So we substitute, become -3 times 2 plus 10. -3 times 2 is -6 plus 10. -6 plus 10 is positive 4. So f of x1 is equal to 4. Next, we're going to find f of x2, and x2 is 7. So f of 7 is -3 times 7 plus 10. So -3 times 7 is -21 plus 10 equals to -11. So now we use a formula. The average rate of change is f of x2 minus f of x1 over x2 minus x1. So we substitute f of x2 minus 11 and f of x1 is 4. And x2 is substitute 7 and x1 is 2. So we simplify -4, 11 minus 4 will be -15, and 7 minus 2 is 5. Divide -15 by 5, so it gives you -3. So average rate of change equals to -3. So here is another example of finding the average rate of change. F of x is x squared minus 5x plus 7. X1 is 2 and x2 equals to 4. So first we find f of x1, which means we find f of 2. So we substitute 2 with the x's, become 2 squared minus 5 times 2 plus 7. 2 squared is 4, 5 times 2 is 10, and plus 7. 4 minus 10 is minus 6. Minus 6 plus 7 is 1. So f of x1 is 1. Now we find f of x2, which means we find f of 4. We substitute 4, so we become 4 squared minus 5 times 4 plus 7. 4 squared is 16, 5 times 4 is 20 plus 7. 60 minus 20 is equal to -4 plus 7 equal to 3. So f of x2 equals to 3. Now we substitute, write the formula, rate of change, f of x2 minus f of x1 over x2 minus 1. So we substitute f of x2 is 3 and f of x1 is 1. So it becomes 3 minus 1 over 4 minus 2. 3 minus 1 is 2 and 4 minus 2 is 2. 2 over 2 is 1. So every rate of change of this function is 1. Even and odd functions. Test for even and odd functions. F of x is even if f of negative x is equal to f of x. Then f of x is even and is symmetric over y-axis. If f of negative x equal to negative of f of x, then f of x is odd and symmetric about the origin. So basically we're saying you are given a function f of x. We want to know if it's even or odd. All you have to do is substitute x equal to negative x. And if f of negative x is the same as the original function f of x, then we'll say the function is even. And if f negative x equals to negative of the original function, then it's what? Odd. But if it's neither equal odd or not even, then we'll say function is neither. So here is an example. F of x equal to x to the 4 minus 3x squared plus 5. We want to know if it's a even, odd, or neither. So as we said earlier, we substitute x equal to negative x. So f of x becomes f of negative x. So wherever is the x, you put negative x. Did you see I put parentheses? So make sure you put parentheses. So next, negative 3 square of negative x plus 5. So find the fourth root of negative x. Since 4 is even power, so it should be positive x to the 4. Again, this should be positive x squared times negative 3 will be negative 3x squared. Okay? So you don't multiply negative 3 with this one. First you find the square of negative x. Since square is even, so it becomes x squared. So it becomes negative 3x squared. And 5 stays plus 5. Now we look at carefully term by term compare. So let's say they're exactly same sign, exactly same. So you can conclude that f of negative x is equal to the original function f of x. And by definition we'll say this function is even and is symmetric about y-axis. So here is an example 11. Function is g of x equals to x cubed minus 4x. So we start with g of x equals to x cubed minus 4x. We substitute minus x for x. So x becomes negative x becomes negative x, and power 3, and negative 4 times negative x. Now since 3 is the odd power, so minus x to the power 3 will be negative x cubed. Now here negative 4 times negative x, negative times negative is positive, so it becomes 4x. Now we compare. Looks like the first one is they are opposite in sign. 4x and 1 they are opposite in sign, so therefore we can say this expression is opposite of this one, which means the g of minus x is equal to the opposite of g of x, and opposite means negative g of x. So we have found the g of negative x is equal to negative g of x, and by definition we'll say the function is odd and is symmetric about the origin. So here is an example 12. We are given a function h of x equals to x times the square root of x minus 1. So we start with h of x equal to x times square root of x, and we substitute negative x for x. So this becomes h of negative x equals to negative x square root of negative x minus 1. This is equal to negative x times the square root of negative x minus 1. Okay, so now if we compare this one, so this they're opposite, but the negative sign under the radical sign is also opposite. So it looks like they are not opposite and they're not exactly same. So we can say h of negative x is not equal to h of x, and that means function is not even. And also h of negative x is not equal to negative h of x. So we say function is not odd. So the answer would be the function is neither. Example 13. F of x equals to x times the square root of x squared minus 4. So we start with f of x equals to x times the square root of x squared minus 4. We replace the x with negative x. So it becomes f of negative x equals to negative x square root of negative x squared minus 4. Simplify. Square of negative x with positive x squared. So now we compare. So it looks like this is exactly same this one, but this negative sign. So we can say this expression, they are opposite to each other. So we can conclude the f of negative x is equal to the opposite of this function. And by definition, the function is what? Odd and is symmetric about the origin.